ఫస్ట్ నేను 11th ఉందా? அதனால 11th நீ எழுதணும். ஆக்சுவலி 11th போட்டு நீங்க நாம பண்ணணும். நேமு, கிளாஸ், சப்ஜெக்ட், பேட்டர்ன். ஓகேவா? Yeah. பெரிய
You connect பண்ணி but we then go to what we did and sorry, என்ன அப்படியே இதுக்கு முன்னாடி கிளாஸ்ல response.
Observation. It frames the apples with of the hand and the feet of you. State my faith. So what does it find to be average? So 1 minus 4. And it's a crystal answer. Which is the correct one?
Chart is to just plug it in. So it will come from one. Okay, then what will be doing? We need to add a new page with two others. So go.
I can use my hand on the other side, right?
No, you cannot use it. You can use it, but not with me.
So with the charge dice, I plug this.
Yeah, it's a way to be just
You should have confidence in yourself. Okay, and you have you did a very good thing. You went through stuff and you asked, you said, you know, there are some things. In fact, one of the problems is what did you say? What did you answer? That way we can, I can show you some interesting problems. Awesome. And do this. This is nice. Okay. We can always have some discussion. We can.
Yes, sir.
Hello. Yeah.
So your voice is not clear.
Can you hear me now?
Now it's clear, but then when you're talking, it's very low.
Okay. Okay. Anytime you feel like my voice is very low, you just stop me and you let me know. Okay.
Okay, sir. Can you just tell me what we're talking about now?
Yeah. Yeah. So we are continuing now, and we are going to look into the concept of average velocity and average speed. All right. Average velocity. So what is average velocity? Guys, it's in the name, it's given. What is average velocity? Yes, that's velocity. So what will be our average velocity? Give me an idea. Good. Not B minus. Good. Correct. Not by 2. Not by 2. By total time. The time. Okay. So average velocity is simply given by our total displacement divided by total time. Good. Are we good? Okay. But if we have to position quantities, let's say it starts at my final position is x2 and my initial position is x1. Let's say that is the case, right? Then what will be my average velocity? It's not going to be plus or there because I want the displacement. You're getting the point, right? The position is x2 and x1. If I add them, I'm not going to get the displacement. The displacement is always going to be final position minus initial position divided by time, the total time. All right. When it comes to displacement, if this x2 and x1 is broken down into two displacements, let's call it this s1, this is s2. Then what is it going to be? My average velocity, total displacement. It's going to be what? Plus s2 divided by total time. Are we clear on this? X2 is the final positions and displacement are different things. Understood, no? If you are in x, if you are starting in x1, that's your position, and you're going to x2, what is your displacement going to be?
X2
Minus x1. So my total displacement is x2 minus x1 divided by total time. So I'm going that I'm going to get my average velocity. But if I have two quantities of displacement, let's say from x1 I want to, let's call this x dash. Let's say from x1 I want to x dash, from x dash I want to x2. From x1 to x dash my displacement is x2. From s dash to x2 the displacement is s1, let's say. So what is my total displacement? S2 plus S1 displacement. Think, imagine.
Okay. You gave the displacement quantity here as x2 and x1 are the position, so we are doing the displacement.
Clear? See, guys, go through this stuff. Make your concepts clear. If your concepts, see these things and all, if you understand, you can solve any problem. If you solve more problems, that does not mean you can do anything. If you understand the concept, that means you can do anything. Okay, fine. Yeah. So similarly, if I have average, if I have something called average speed, what am I going to define this as? Total what?
Total distance by total time.
Awesome. Yeah. Even I might have to leave early. So we'll go together. Huh? Okay, cool. Cool. We'll go together. Even I might have to leave early. Okay. So this is clear to you all. So now we come across a concept called instantaneous velocity. What do you think is instantaneous velocity? Hmm? No? What does it mean? Instantaneous. Instant. Good. So the idea is that an average value of velocity is going to give you the average thing. It's total displacement by total time. But if I want to know at every instant of time, what is the velocity? That is called instantaneous velocity. So I have a car and I have your you have an acceleration. It gives you instantaneous acceleration. At every moment of time, how much the acceleration is, it is giving you immediately 40 kilometers per hour, 35 kilometers per hour at that moment. Similarly, if I want to check for velocity, it is called instantaneous. Instantaneous velocity. That's about it. Okay. So the way this is defined physically, now we have to define this in the physical terms. So what we're going to have is, we have the same thing. We have delta. What happened? So what do you have? We have you understood what delta R is, right? By delta T, you know what these things are, right? It's change in position vector. R is position vector. Delta R is change in position by delta T. But this is not enough. What I'm going to do is, okay, what I'm going to do is, I'm going to write limit delta T tends to 0. Do you know what this means? You guys don't know what this means. Okay, we're going to talk about it now. Okay, my instantaneous velocity is going to be delta R position vector, obviously delta T. Sorry, line will not have direction. So the idea is that I have time along my x-axis, correct? I have position along my y-axis. Let's say my position is changing like this. Okay. So what does delta mean? Delta R by delta t. If delta means I'm going to change. Correct? So the idea is that I take one small portion. Delta means you're dividing it into small portions. Right? Delta also means change. But delta also means small portion. And the change in that. That's the idea. R2 minus R1. That's all. Or delta is T2 minus T1. That T2 can be small, it can be very big. So what I'm saying is, see, this is also delta T, correct? T2 minus T1. This is delta T. Correct, no? Or I can make, let me call this delta T1, okay? Fine. Now I divided it into a smaller part and I called this here, this instance as T3. Now I define delta T2 as T3 minus T1. Are you getting what I did? Huh? I took a smaller portion, correct? And I called it delta T2, smaller portion. Okay? Is this clear? Or let me, for the sake of not confusing you with numbers, let me use notations. TA, TB, TC. Okay? So what is this one? TC minus TA. This is going to be TB minus TA. Understood, no? Which one is a bigger delta T? So that is delta T1 is delta T1 is a bigger change than this one. So my idea is this change no delta T. I'm going to make it smaller, smaller, smaller till delta T is almost zero. So then what will happen is at that delta T, it's almost like I'm getting the value at that instant. Are you getting the idea? My delta T, I'm going to make it smaller. I don't want this big change. This is almost like an average value because my range is so huge. TC minus TA. It's like it's not getting anything at the instant. It is only telling you what is the total. I don't care about the total. I want to know the instant. So make what the delta T make it smaller. Okay, I make it smaller. Are you satisfied? Not satisfied. But still the range is quite big. I want to know what is happening at the instant. So what I do? Make the delta T even smaller. To the point where I'm saying I'm limiting. It's called limiting delta T. That delta T is approaching zero. It's almost approaching the change is becoming so small that at every instant it's like I am getting the instantaneous measurement. Is that clear? Is the idea clear? Right?
So, sir, in order
Note these things down. When you read it in your textbook, you may not understand. It does not. This is the formula for instantaneous velocity. Okay?
Sir,
Yeah. Limit LIM. Okay? LIM is used. LIM. Arrow 0. Arrow means approaching 0. It's called limits. Limits. We are putting limits. Okay?
So, sir, in order to bring it to zero,
Now.
we again have to reduce the area. So, delta T3 it will be like delta
Some other quantity.
correct. So it will keep on be going.
Yeah. So the thing is, no, we don't do it again and again. From the beginning only, we are taking delta T. See, I have given you an example earlier that I have taken different. Right. This is for your understanding. But mathematically, we are from the beginning only we are taking a very small quantity. Okay. It's already approaching 0. It's not starting from big to approaching 0. It's starting from small. Right? You are understanding, right? It's not like you're cutting big pieces of onion and eventually you're cutting small pieces of onion. That makes no sense. Because then you have pieces which are big pieces, small pieces. I'm telling from beginning only limit your cutting, make it small. I want small instance. You got the idea? Okay. This guy. Come here and is this correct? Oh, where? This one. There's a gap out here. It's not starting at 0, you're saying. That's okay. Okay, ideally it should start at 0. That's fine. That's not a big deal. Okay, because sometimes it may not start at 0. Some things don't have to start at 0. Okay. Let's say a car starts. Does it start? It starts at 0, yeah. But if the acceleration is very high, it's almost like it's from 0 it has gone to a very high value. That your rest almost sometimes your rest does not come into the picture. It's almost as if the initial velocity was always quite high. Let's say you are having a car, you're having a Ferrari, you want to check its acceleration or something. Move its velocity for 1 hour. What you'll see is the 0 initial velocity was only remained for a short period of time. Then it jumped immediately. The velocity became high because it's a fast car. And over a period of time, it either remained constant or it increased or it decreased. But at that scale of things, when you're comparing, that scale almost nothing. Okay? You getting the idea? Right? Similarly, we define instantaneous speed. Same thing. Our my instantaneous speed is going to be just position. R is your position vector. It could be initial, it could be final, depending on the problem, depending on the situation. Just like V is used to denote velocity. That doesn't mean V itself is initial velocity. Depends on the situation. If they say there is some initial velocity, say Vi or something like that. Or I think you guys have used U. That's fine. It's up to your understanding. Okay? That's all. Instantaneous speed in the similar way, what can we define it as? Delta S by delta T. And what will come out here are limit. We are limiting it to 0. Alright? Is this much clear to you guys? Okay, so we will go further. It's 6:30 now. No? So are you guys familiar with the concept of slopes? Slopes. So the idea is basically very simple. You know what a tan is? So if I have a quantity like this, and this is my x-axis, and this is my y-axis. Okay. And this is the line I did theta. Can you tell me what is the tan theta? Opposite side by? Come on, say P. Do you believe it?
Yeah.
No, no, don't think, you just tell me, what is it?
Opposite side.
That's all. Opposite by adjacent. Cool. So what is going to be my opposite? This side. And this is going to be my adjacent. Correct. But do you see that this opposite, let's say I have 0 and this point is called y1. Okay. This point is called, I call this x1. I call this one x2. Just imagine. Okay. You understood the graph now? So can I say that my opposite what is going to be my opposite? Let's call this y2. I call this y1. So what is it going to be? Initial is y1, final is y2. Awesome. y2 minus. And what is going to be on my denominator? Or can I call this delta y by delta x? Right? Or can I call this y by dx? Same notation. Same meaning, different. Same meaning, different notation. Okay? This is called as slope. Dy by x. It's also differentiation. It's some sort of differentiation. It's differentiation. Are you guys familiar with differentiation? You completed, no? Yes, completed. You have completed. Why you didn't complete it? Okay, fine. Don't worry about it. Okay. So now the idea is quite simple. Okay. Note this down. This is called.
We are representing V by dx as delta y by delta x.
No, we do that sometimes. Delta just means a change in something or small quantity of something. I can even call it dy by dx. Okay. Which means difference in shape. Change in something. So this is called a slope. Okay.
Slope d by dx formula we can find y2 minus x.
Come again.
Slope formula we can find y2 minus x. That's y2 minus.
Yeah. So this can be used in different ways. This can be equal to this. So if you are finding where slope of this is this. So you understand this is the final value. That is we use this idea of differentiating because the idea is this. I'll show you. Now, along my x-axis, I will have displacement. Okay, we'll call it S. Is that fine? Are you comfortable with S being displacement? Fine. And along my y-axis, I'll have time. So now I have something like this. Let's say some graph I have random. Okay. So what is going to be my slope here? D. What? D. So what is my y here? S. No? ds by dt. So okay.
dt by ds.
ds by dt.
Yes.
dy by no y-axis. Which is y-axis? Which is x-axis? Now. Think.
It's not bad.
Fine. You see. So what is my slope here? So this is my displacement versus what? So what is going to be my slope here? ds by dt. So what is this ds by dt? What does that mean? The change in displacement by
Changing that time.
change in time. What is that?
Average.
Velocity. Let's call it velocity. Whatever velocity. We don't know how big ds or dt is. Average is when it's very big. When we are limiting it to zero, bring it to a zero, it's instantaneous. We just call it velocity. This is my velocity. Interesting stuff. The slope of my displacement versus time graph is giving me velocity. Cool stuff. And the interesting thing again is the velocity versus time. Okay. Now what I can do is I take my okay. So now what I'm going to do is I'm going to take another graph, and along my y-axis I'm going to have velocity. Along my x-axis I'm going to have time. You can note these things down, okay? And something I have random. So now what is my graph? Velocity versus time. So what is going to be my slope here? B. What is the change in velocity per unit time? Velocity is, we don't know. Acceleration. Okay.
Same formulas, it's just the same, but different symbols for angular. The same formulas are playing when we calculate the angular quantity of the same quantities that we are doing now. For example, like A will become alpha for angular acceleration.
Yeah. The notations are different.
And three notations are different, but it's the same process.
Concept is similar. Concept, but it changes angular velocity, angular acceleration, or angular that is called angular acceleration. It's angular velocity.
Just doing the same thing, but the notations are different.
It's the process is also slightly different. Is this much clear to you guys? And the interesting thing is, now see, just look out here. Look into this for a while, same thing. So I have a curve now. If I were to draw the area under the curve and I was to find the area under the curve, like this is my curve, I find the area under this. What I'll get is very interestingly the area under this curve will give me the total displacement. Okay. So if I this is my curve, I can find the area. This area is what is the area? This is the triangle. What is my area of the triangle? Half base into height. So let's say this value was, let's say, here it became 5, and the height was, let's say, here it was 10. So what will be my area? Half into half 5 into 10. So what is it? 25. So 25 is my displacement. It comes out to be equal to displacement. If you knew about differentiation and integration, I could have explained to you why, but since not everyone is familiar with it, you just believe me for what I say. It's just a one-line explanation. You will understand when it goes done. I'll talk to them about it. They will maybe in next class they will do differentiation and integration further.
So, slow down.
So just to summarize, all the graphs are only speed velocity and
Velocity data.
only limits of this.
Area
Under this curve.
So from displacement we get velocity, and from velocity we get acceleration. So it's integration.
Huh?
This thing is integration, the area.
Yes. So similarly, can we so you understood this concept, right? Slope, what is slope, and all of this you have understood, right? So there will be many times in the future when you have to find slope of a graph, or when you have engineering, you may have you will have to know about slopes and things. So slope is simply dy by dx. Something will be along the y, something will be along the x. Dy by dx is the slope of any graph. That here, and that will give you some useful information. Okay, so always this, depending on the application and depending on what concept it applies to, what it gives you will be different. And here it's given these things, and in fact, this is not very difficult to understand. See, change in distance by time. So what is distance? What is the unit for distance? What? Meter for distance, meter per second, meter per second. That becomes our velocity in units. Okay, meter per second. Similarly, now we already have meter per second. For what? For velocity, velocity is meter per second. By time is second. So what? Meter per second square. Clear? Go through these things. Right? Alright. Similarly, we can define something called instantaneous acceleration and average acceleration. Same concept. Instantaneous acceleration is acceleration at an instant. I can so delta V delta T, or I can write it as dV by dt. Okay, but what happens are here instantaneous. So what I have to do for a given instant, I have to limit it. Amazing. Limit to 0. Delta T approaches 0. Okay, clear? Fine.
What is it?
Acceleration A. Instantaneous. INST orbital. Instant. INST instantaneous. Stands for instantaneous at the instant. So similarly, we can do this. Okay, I don't know if you know about these notations, but sometimes what you want to do, if you want to write initial acceleration, you can just write I A. Now you write initial or INI. Down INI. If you want to give final acceleration, A down final or AF or something like that. It's up to you. You are understanding. Okay. So similarly, okay, this is clear to you. And I can write, if I want to write about average acceleration. Yeah, but I can write it as AVG. Just for your understanding, okay? Clear? Yes. I will write it. Now, knowing all these things, can we do some interesting problems very quickly? Okay, note it down. On a 60-kilometer track, on a 60-kilometer track, a train travels the first 30 kilometers and on a 60-kilometer track, a train travels the first 30 kilometers at a uniform speed of 30 kilometers per hour. Okay. On a 60-kilometer track, a train travels the first 30 kilometers at a uniform speed of 30 kilometers an hour. That much. So for the how fast does the train travel the next 30 kilometers so as to have an average speed? How fast does the train travel the next 30 kilometers so as to have an average speed of 40 kilometers per hour, so as to have an average speed of 40 kilometers per hour for the entire trip. Okay. Write down what we know first. Try to draw a diagram for your understanding. Write down what you know. Write down what you have to find out. Okay.
Excuse me, sir.
Yes.
Could you repeat the uniform speed?
Can I repeat what?
What is the uniform speed of the train?
The uniform speed is 30 kilometers per hour. Okay. Is that it? Did you get the rest of the question?
Yes, sir.
Okay.
So 30 kilometers.
The velocity. If you stop. How many of you are getting the way to answer? You are getting somewhere? You're feeling like you are getting it. Are you feeling like you're getting it? You're kind of stuck, right? Remember, speed is equal to distance by time, and those interchangeable things. So if you plot for one particular value, you can also write it in terms of service. So that wherever it is, think about it. And you do maths, and then I'll solve it. Everybody, are you sure we have to use at sin 50? You cannot extend by 10 minutes or something. No, you have to because there's something important that I want to start discussing. So I don't want to miss it, but let's see. Otherwise, it's better not to start that part and start with the next class. We can put that slightly back. Okay, stop. Enough time. If you're getting it, you can continue doing it. Always. Anything? What is the bizarre answer? 1.3. 1.33. 6.66 or something.
6 by 5.
No. You are 6.5, 1.33 kilometer per hour. That's wrong. Take that we are going. Okay,
Yeah.
you're giving an educated guess. It's called an educated guess. I'm guessing, but I have knowledge. That's called an educated guess. Yes, educated guess. Okay, fine. So what do you know? So okay, wait. Listen. So this is my total S displacement. If this is my S1, this will be my S2, correct? What? On a 60-kilometer track, the train travels the first 30 kilometers. So S1 will be, I have divided the whole 60 kilometers into two displacements. One is S1, another one is S2. Always, if you have given something and that is a divided, no. Like first 30 kilometers you did this. Then you always divide the whole thing. Split it into two parts. Okay? Because they have given it in a way such that you have to split it into two. That is the idea. Is this much clear to you what they have done earlier? So what will be my S1?
30,
Yes,
30 kilometers.
30 kilometers. Okay, good. So my S1 plus S2. What is my S1 plus S2? Okay. So then let me write my S1 as, like this guy said, 30 kilometers. What will be my S2? 30 kilometers. Awesome. What do I know? What else do I know? V1, 30 kilometers per hour. And what do I have to find? V2 is what I have to find. Okay. Clear? So what they have told me again? They have told me something.
Average velocity.
They told me average velocity. So they have given me average. The average speed or velocity? Okay, average speed, fine. Average speed is what? 40 kilometers per hour. Good. So, do we know what average speed we can? I'll just write this as V average. Just look at me first, okay? See what I'm doing. So, what is V average? What is average velocity or average speed? What is that? Formula. Formula. Average. Total. Awesome. I'll just write this. You understand what it is. Alright. Clear. This much is clear. This will be equal to S1 plus S2 divided by T1 plus T2. Clear. I know what is my S1. What is it? 30. Okay, 30 kilometers. Do I know my T1, T2? I don't really know, but what is it? This speed is equal to? No, I can write it in this way. See. Yeah, speed is equal to distance by time, which implies my time is equal to distance by speed. Okay. I wish I could continue writing up here. I'll continue up here, okay? So that there's continuity. Fine. So up will be 60 obviously. This will be what? As this distance by speed of it, right? Okay. S1, this notation will confuse you. Okay, fine. S2 by these values I know, some values I know, some I don't know. Can I find it out? Yes, do it. More I don't want to. It's won't fit you. Okay. Happiness is zero somewhere. Yes, 60.
So,
You were right, but
but I scrap it up.
so you are wrong. But good. See, that is the problem, man, in life. We are always right something many times, but eventually, if it does not happen, no, it's gone only.
Not of distance, and I scrap displacement.
But you got the idea, right? Always remember, if they told you instantaneous velocity is given, average velocity is this, they means they want you to use that starting. So they're giving you average velocity or average speed. So you're like, okay, start with that formula because that is what you will use for the rest. Okay. Are you able to do it? Did you get the answer? 30. It should be 60, okay? Yeah. Here, divided by, it will be 60, it will be 30 divided by 1 by 2, the 2 will come up. Or 30 divided by 0.5.
60 by S1 by V1, S1 by V1 is 30 by 30. So it's 1 plus is 2 by
40 on one side, 60 on another side. Okay. What is my S1? 30 by 30 plus 30 by V2. Okay. So 40 is equal to what? 60 divided by 1 plus 30 by V2. I can bring this up. So it's going to be 1 by 30, 1 plus 30 by V2, which will be 40, 60 by 40. 60 by 40. I've taken this up on the other way. Okay. So this is going to be my whatever 3 by 2 is what I will be, correct? Roughly. So I can make it 1 minus 3 by 2. On the other side will come 30 by 2. What is 3 by 2? It's half. It's 1.5. So it will be 1 minus 1.5 equal to 30 by 2, which is equal to 0.5, 30 by 2. So V2 will be equal to 30 divided by 0.5, and 0.5 is nothing but half. Right? So 30 by 1 by 2. Is that so difficult?
See, for what is that? I'll just wait. It's basically the denominator of 60 by
Which step is there?
how is 60 by 1?
This is the numerator. This is the I can slab this to you know that concept. So
So S2 by V2, like that part. S2 by V2. Below wants V2. So let's say we use X and we will just get X plus 30 by X. Because X plus 30 by X.
So you have gone through that way, I think. Okay.
So like we are doing that. Now we are replacing the denominator by 40. So we get X plus 30 by X.
X plus
30 by X
hmm.
is equal to 60 by 40. So X,
There also you can do something. X, what did you say? Come on.
X plus 30 by X equal to 60 by 40.
Okay, what is it? What is it? Come on, tell me the equation.
X plus 30.
Tell me slowly. I need to write it down. What is it? No, this equation you tell me.
X plus 30 by X
X plus 30.
by X.
So both are common denominator or only under 30? Okay, by X. Okay, is equal to 3 by 2. So, so what you're going to do now is this is the denominator, this is the denominator, this also. It's just solvable. I can write this as X by X plus 30 by X. Correct? Correct? Is equal to 3 by 2. Correct? What is X by X? 1. Okay. Let me write this out here. So it's going to be 1 plus 30 by X is equal to 3 by 2. What is 3 by 2? 1.5, right? 3 by 2 is 1.5. Okay. So what happens? I take this to the side, I have 1 minus 1.5. On the other side, I have minus 30 by X. Right? No. Minus. Okay. 1 minute. Let's do it this way. No, if he has gotten it this way. So what is 1 minus 1.5? Minus 1.5. Minus 0.5. So minus 0.5 is equal to minus 30 by X. If you solve this, you get the same answer. X will go to the other side.
X plus 60, 3x equal to 2x plus 60.
2x is equal to X
X equal to
60.
that's the answer.
Yes.
I thought X equals X equal to 60.
It's correct.
I got it right.
Got it? Everything is the same. The pot is the same. Doesn't matter in which order you put the ingredients, and then you'll get the same curry. Okay. And you can do it this way, you can do it that way. But everything is the same. No, equations are the same, values are the same. Whichever way you do it, you get the same answer. Okay? All fine? Doubts are clear? Good. We'll do one more. Note this now. two buses started simultaneously. I repeat, two buses started simultaneously towards each other. Two buses started simultaneously towards each other from towns A and B. Okay. Two buses started simultaneously towards each other from towns A and B, which are 480 kilometers apart. Towns A and B, which are 480 kilometers apart. The first bus traveling from A to B, I repeat, the first bus traveling from A to B took 8 hours. The first bus traveling from A to B took 8 hours, and the second bus traveling from B to A took 10 hours to cover this distance. I repeat the sentence. The first bus traveling from A to B took 8 hours, and the second bus traveling from B to A took 10 hours to cover this distance. Determine when did the buses meet after starting. Determine when did the buses meet after starting, and at what distance from town A. I repeat. Determine when did the buses meet after starting, and at what distance from town A. Okay. Assume that both buses travel at constant speed. I repeat the question. Two buses started simultaneously towards each other from town A and B, which are 480 kilometers apart. The first bus traveling from A to B took 8 hours, and the second bus traveling from B to A took 10 hours to cover this distance. Determine when did the buses meet after starting, and at what distance from town A. Assume that both the buses traveled with constant speed. Assume that both the buses traveled with constant speed. So you have the total distance between the two towns. You know their individual times. Tell me.
Assume that they are constant speed, but they have the distance and you have the time they travel, but they are not differently far. They are not 20 kilometers of difference.
Just think about it. Think about it. Okay, come on. Then. This is the time. Define this one speed. Define this one speed. Okay. So now we know the total distance. So then what is the meet? So you know the total distance. What we distance. You know the speed, right? Find distance. Okay, now what is the dimension?
Speed, we assume that they both are constant. But they have different speeds when you find out the speed using the distance.
Yeah, correct. Yeah,
So
so
how can I assume that they are constant?
this is their total distance. Yes.
Constant speed means that only less gravity.
So you have speed. Yes. So you want to divide something by here. You know the total value of something. Right? You know the total distance. That's did you also find individual speeds? So now the idea is I know the total distance. I'm assuming everybody found speed. So I know the total distance. What is it? 480 kilometers from A to B. So can I say I'll act like okay, they are going to meet at a particular place. The meter here. So I write this total distance is equal to distance 1 this is your 2 and 480 on this side and the other two is both will take the same time for it because they meet each other, correct? The time both of them take will be same. If I start that stopwatch, the moment these two stop, if I start the stopwatch, they meet somewhere. I stop the stopwatch. Obviously, the time that both are taking is same. Do with this information what is very important. What time?
Get the whole process.
372 more. So find T first for me. Find T. What is T? 372 is T, is it? Huh? So can you divide by 60 and tell me? That will be 372. It will be in terms of what? Distances are in terms of kilometer and are talking in terms of times your time you're talking in terms of hours. No, you don't have to divide it by 60 because divided by 108, we actually get it in hour only. 4.4 hours. Yeah, that's 3 minutes. 4.4. No. 480 divided by 108 is 4.4. Okay. So now can you find the distance from A? You made some error. You made some error. No, you understood what is the error, right? Don't do it again. Making mistakes is fine, but we have to realize that we're making.
From here was what first was 26.
26.
26.
Will be 266.
Yeah, 26 point. Oh.
Two sessions. 266 like that.
Point is there, like
Point something like that.
16.
So did you realize that if you can see mistakes in math? If I would get each and every so the best, but that's in the error, the answers are with you. Okay. Doesn't matter how accurate your method is. You have to be. So she. Good job, Ananya. Ananya, it comes around 266, but that's fine.
Okay, sir.
Yeah, you can calculate that. The same thing we do, you just multiply and you multiply. Huh? She got 264. Right? The answer is 266.7.
Because of the division rate,
How do you know distance is equal to what? Speed into time. No. Speed, you know, no. What is speed? We had calculated it before. 60 kilometers per hour, we had calculated. And that we multiply into time. What is the time? 4.4 hours.
So this is
Very
just
direct.
these two numbers. Yes.
Yeah, good job, Ananya. Ananya, just depending on how you do the substitution, it will change it slightly.
Okay.
we entered 4.2.
Okay, maybe class will do the location based on that. What's our location based on? Okay. Yeah, good. Okay. So you have to leave now. It's 2:18. You leave. We'll wind up for now. Because I mean I know it's 10 minutes early, but the thing is the next topic it takes proper 20 minutes to 30 minutes of time. And we'll have questions, we'll have doubts. Does that not do it properly? It makes sense to do it in the next class. Is that fine? Go through these things. Concepts are clear now. Solve it. It takes practice. Like this, it will not click. You have to practice things. Go through your textbook, go through this. There will be problems on the same basis. Solve them. Solve a couple of them. Okay? You'll get a proper idea. Get a proper grip of the subjects and do it well. Is that good? Okay. No problem. Ananya, we are winding it up for now, okay? Because the next topic takes quite a while to complete. So it makes sense that we start in the next class.
Okay, sir.
Okay? Till then, Ananya, what I want you to do is I want you to go through your textbook and all. And if you can find similar problems, I want you to solve them. Because such things take a while to, for it to sit in your head properly and perfectly. So just solve them, practice, and be clear with the concepts, okay?
Okay, sir.
Yeah.
Thank you, sir.
Meanwhile, the exercises have to be a complete frame.